Find the complete solution or show that the system is inconsistent. X plus 2y minus z equals 1, 2x plus 3y minus 4z equals negative 3, 3x minus 6y minus 3z equals 4. We will solve this equation by obtaining an equivalent system of equation in triangular form. Observe that we can get rid of the 2x in the second equation by multiplying the first equation by negative 2 and add to the second equation. This is negative 2x minus 4y plus 2z equals negative 2, where we took the first equation and multiplied negative 2, and then we add to the second equation, which is 2x plus 3y minus 4z equals negative 3. We add the two equations column-wise. Negative 2x plus 2x is gone. Negative 4y plus 3y is negative y. 2z plus negative 4z is negative 2z, and negative 2 plus negative 3 is negative 5. We also want to obtain the leading term positive, so we multiply this new equation by negative 1 to obtain y plus 2z equals 5. This will be the second equation in the new equivalent system of equation. We can also get rid of the 3x in the third equation by perform similar operation. We take the first equation, multiply negative 3 and add to equation 3. This is negative 3x minus 6y plus 3z equals negative 3, where we took the first equation, every single term, and multiply negative 3. We then add this to the third equation, which is 3x minus 6y minus 3z equals 4. We add these column-wise. 3x minus 3x is gone. Negative 6y plus negative 6y is negative 12y. 3z plus negative 3z is now 0z, and then on the right hand side, negative 3 plus 4 is 1, and this will be the third equation. We obtain an equivalent system of equation where we keep the first equation, x plus 2y minus z equals 1. The second equation is now y plus 2z equals 5. And the third equation is negative 12y equals 1. We observe that the last equation has only y, so we want to interchange the second and the third equation to obtain an equivalent system of equation, x plus 2y minus z equals 1, negative 12y equals 1, and y plus 2z equals 5. But we can divide by negative 12 from both sides of the equation 2 to get x plus 2y minus z equals 1, y equals negative 1 over 12, where we took equation number 2 and divided by negative 12. The third equation is y plus 2z equals 5. And then we used the second and the third equation to get rid of the y in the third equation by taking the third equation, equation 3, minus equation 2. This is equivalent to taking the negative 1 times equation 2 plus equation 3. An equivalent system of equation is now x plus 2y minus z equals 1, y equals negative 1 over 12. And if we took the third equation minus the second equation, y minus y is gone, 2z minus 0z, is now 2z, and 5 minus negative 1 over 12 is, the common denominator is 12. We get 60 plus 1, or 61 over 12. This is now a triangular form where z is 61 over 12 divided by 2, which is 24. Y is negative 1 over 12. And to find x, we use back substitution. The first equation is x plus 2. Y is now negative 1 over 12 minus z. Z is now 61 over 24. The right hand side is 1. This is x minus 1 over 6 minus 61 over 24 equals 1. So x equals 1 plus 1 over 6 plus 61 over 24. The common denominator is 24, so we would multiply 24 over 24 to 1. We would multiply 4 over 4 to 16, and we can combine these fractions with the denominator of 24. The numerator is 24 plus 4, which is 28. 28 plus 61 is 89. The solution of the given system of equation is therefore an ordered triplet with x equals 89 over 24, y equals negative 1 over 12, and z equals 61 over 24.